Alright, so in this video, all I'm really going to do is just kind of introduce you into what we're going to be talking about in our next class. So the first thing I kind of want to go over is I want to define what a number sequence is. So a number sequence is nothing more than just a list of numbers that have a first, second, third number, and so forth. So it's just a list. Now, an easy one would be something like 2, 4, 6, 8, and so forth, okay? So this is a sequence of numbers. Now notice that I have a first number 2, the next number is 4, and so forth. Now sometimes we could get lucky and we can look at this list and say, oh, okay, well, 2, 4, 6, 8, those are even numbers, and we can come up with what we call a general formula. So this 2 times n is going to generate all of the values within this sequence. And the thing that I always like to do, and it's not me, I mean, this is everybody, is that when you come up with a general formula like 2 times n, you got to let me know what n is starting with, and then you let me know where it's going. Now, these 3 little dots that I wrote here and here, they're called ellipses, and they just mean to keep going. So if I were to use this general formula and I let n equal 1, 2, 3, 4, and so forth, it's going to generate all of these numbers within my sequence, okay? Now, there are different types of sequences that exist. Now, the other day in class, we looked at the arithmetic sequence. We looked at a geometric sequence. Okay, and then we also looked at a recursive relationship or recursive sequence. All right, so what we're going to do is we're really going to look at arithmetic first. Okay, so I'm going to list some numbers here. Here's our first sequence. And notice that if we start with the very first number 5, and we ask ourselves, well, how can we get the 9? Well, what we could do is we could say, well, we can just take 9 minus 5, and that gives us 4. Now, will that apply for the next number? So, in other words, 13 minus 9. Well, 13 minus 9 is also 4, okay? And then I can look here, and I can say, okay, well, 17 minus 13, well, that also equals 4. So, because within this sequence, we have this common number of 4 popping up. We call that number 4 the common difference. All right? And whenever a sequence has a common difference, we call it an arithmetic sequence. That's how you know it's arithmetic. It's because it has a common difference. Now, sometimes this might not be readily apparent. For example, your book has this example right here. Okay, and this is another sequence. And if we tried to do that method that we just did, we tried to take these 2 numbers, 6 minus 2. Notice we get 4. Then we get 22 minus 6. And notice that's 16. And then we get 56 minus 22. And 56 minus 22 is 34. And notice that we're not getting what we wanted, which is this nice common difference, okay? However, let me write this out real fast. In fact, I'm going to give myself some space. Watch what happens here, okay? So I subtract these 2 numbers right here. 6 minus 2, we know that's 4. 22 minus 6, we know that's 16. 22 minus 56, we know that's going to be 34. And then 114 minus 56 is going to be 58. Now, it looks like there's really nothing going on here, but if we continue to do this, how about 16 minus 4? Well, that's going to be 12. And 34 minus 16, well, that's going to be 18. And 58 minus 34, well, that's going to be 24. Notice now, it's starting to starting to see something here. Well, what's 12 minus 8, or what's 18 minus 12? Well, 18 minus 12 is 6. And what's 24 minus 18? Well, that's 6. Okay? This row right here gives us the arithmetic sequence with a common difference of 6. And this method that we used is called successive differences, okay? So you got to be careful when you're doing this, because sometimes you may have to use successive differences 1 or 2 times, all right? Now, I'm not going to make this so it's overly difficult. I mean, you're going to be able to kind of see what's happening, and I also give you like a little hint. I say, hey, you might want to try successive differences here, okay? Now, let's look at the other type of sequence, which is a geometric. Now, geometric sequence has what we call a common ratio. All right? So let me show you a really easy one here, okay? So we're going to do 3, 9, 27, 81, and so forth, okay? So with this sequence, we're going to take the 2 numbers and we're going to divide them. So if you notice, I get 9 divided by 3, which is 3. Okay? Then we'll take the next 2 numbers. 27 divided by 9, well, that's also 3. And then if I take the next 2 numbers, well, 81 divided by 27, well, that's also 3. Okay? So I can see here that by dividing the next term by the previous term, all right, so let me write that here, next term and our previous term, we're always coming up with the same exact end result, which is 3. And that number 3 is what we call the common ratio. Now think about what the word ratio means. Ratio is just a really fancy word for a fraction. And when I write 9 divided by 3 in fraction form, that's a ratio, and I'm always getting that common number of 3 as an output. So we get a common ratio of 3, which means we can use that to our advantage. So for example, if I asked for the next term in this sequence, well, all you would have to do is take 81 times 3, and that's going to give you the next term. So 81 times 3, sorry, I got to use my calculator, is going to be 243. So this would be our next term. And then we can keep following, we can keep finding the next term and the term after that, and so forth. The hard part is determining whether or not you have a geometric sequence or an arithmetic sequence. That's the hard part. And the only way you're going to get good at that is just by looking at different sequences and then trying to determine which one it is. Personally, try the arithmetic sequence first, all right? Because that's always the easier of the two. If nothing's working, then try a common ratio. And you may run into a situation where the sequence of numbers that you have is neither of those. And that is that one that we looked at in class. I'll write it in blue, which is the Fibonacci sequence, which is neither arithmetic nor is it geometric. So the Fibonacci sequence looks like this, and it's a recursive relation, meaning that we need to know information about the previous number in order to predict the next one. So 1 plus 1 equals 2, and notice that 2 is right here. Okay? Then 2 plus 1 is 3, and notice that's right there. And then 3 plus 2 is 5, and notice that's right there, and so forth. Okay, and that's going to be it for this little overview. When we come back into class, we're going to be going over the sequences. We're going to be looking at different examples of them and how to actually generate terms for them or determine whether or not we have an arithmetic or geometric. And if neither of those work, we're going to try this recursive sequence where you take the two numbers, you add to get the next number or something like that. Okay? That's going to be it, and I will see you in class. Later.